This video will be on section 3.3, which is on zeros. Then we'll start with the definition of a zero of a function. Then we'll look at determining the zero of a function with a formula. Like we have most questions, there will be a formula. But we can also look at the zero of a function given a graph, and it has a special name when we're talking about the graph. All right, so the definition of a zero of a function, you can kind of guess what it is because of it's right in the name. The zero of a function is an input x that makes f of x equal 0. Right, so there's really one thing people can mess up on, and that's plugging in x equals 0, which is not one you want to do. We replace f of x or y or whatever it is with 0. And then we solve for x. One thing I want to mention here, because it's relevant in the problems, is you might not have any zeros, but you can have more than one zero. But really, a lot of this section that's not very long, it's really not any different than the solving equation section we did. When you set equal to 0, then it boils down to solving an equation. All right, so for the following, let's see how many we have. We have 4 questions here. Determine the zeros of the following functions. If there are no zeros, write D and E. So that's a possibility. All right, so the first one here, we got h of x equals negative 19 plus 6 over 7x. Well, we start by replacing h of x with 0. Then solve for x. And so we got 0 equals negative 19 plus 6 over 7x. We want to solve for x. You can get rid of the fraction now, or you can wait. It's up to you. I'm going to wait after this first step to get rid of the fraction, because it's a little bit easier to do this first. If you add the 19 to each side, then we got 19 equals 6 over 7x. And now if we want to get x by itself, if we want to cancel the fraction, we multiply each side by the reciprocal. Which is the flipped fraction. So we multiply each side by 7 over 6. What that does is that cancels out the 6 over 7 because the 7 on the top and bottom cancel. 6's cancel. And on the right side, we have just x. On the left side, we have 7 over 6 times 19. If it helps, think about 19 as 19 over 1. 7 times 19 is 133. 6 times 1 is 6. And that is our 0. Once you get the x value, you're done, or values. Number 2, we have the function n of x equals 15. Well, we do the same thing. We replace n of x with 0. We got 0 equals 15. And this should send out a little bit of an alarm because there's no x here. 0 does not equal 15. So this is actually just D and E. There's no x to solve for. And 0 does not equal 15. All right, so if you don't have an x in your function, if it's just a number, that number's not 0, then there are no x-intercepts. There are no zeros, rather. All right, so number 3, We've got j of x equals 4x to the fourth plus 4x cubed minus 120x squared. Once again, we replace the function name with 0. And we solve for x. So this is something we have different powers of x. You're going to want to try to factor it. First thing to do is definitely, for this one, find a common factor and factor that out. And the greatest common factor, don't miss that we have a 4 in common for 4, 420, or 120. And we can also take out an x squared. If you miss the 4, you'll make the problem harder than it has to be. Right, so if we take 4 out of 4x squared, x to the fourth, we get rid of the 4, and then if we take the x squared out, we are left with just x squared. Plus, take 4x squared out of 4x cubed, the 4 is gone, and we took 2 out of 3 x's, we're left with just x. And then finally, if we take 4 out of 120, we have 30, and then x squared out of x squared, there's no x's left. Right, now we can factor the inside. We have just x squared there, though that makes the problem easier. We want two numbers that multiply negative 30 and add to positive 1, and that would be positive 6 and negative 5. And now we have it set equal to 0, which automatically happens the way the problems are. So set each factor equal to 0 and solve it. We got 0 equals 4x squared. The thing in front, 0 equals x plus 6. And 0 equals x minus 5. Right, the one on the left, we want to get x by itself. We divide by 4. We got x squared equals 0. 0 divided by anything is 0. And then, we could do the square root, but we don't need to. We just remember that x raised to any power equals 0 means x equals 0. We don't have to do any extra work. But if you do the square root, the square root of 0 is 0. So the plus or minus 0, that's just 0. Second one here, subtract the 6 from each side, and we get x equals negative 6. And then the last one, we add 5 to each side, and we get x equals 5. Right, so we happen to have 3 answers here, which is quite all right. We got 0, negative 6, and 5. Now we got one more. This one's just a reminder of the AC method that doesn't go away for factoring. Here we want to find the zeros of the function f of n equals 5n squared plus 7n minus 24. We replace the function name with 0 again. And then we factor this. There's nothing in common to factor out, unfortunately. So we factor using the AC method. All right, so remember when we do that, we multiply the front and the back numbers together, the A and the C. 5 times negative 24 should give you negative 120. And that means we want two numbers that multiply to negative 120 and add to positive 7. Right, and you might have to, this one might not be as quick as the other ones because negative 120 has a lot of factors. And so 120 and 1 would not work. 2 and 60 would not work. 3 and 40 would not work. 4 and 30 would not work. The original numbers never work. 5 and 24 won't work. Well, they might occasionally work, but that would be a really weird question. 6 and 20 won't work. 7's not divisible. 8 and 15 will work. And because we want it to add to a positive number, it's 8, negative 8, and 15. All right, so now we want to form our factors. We want to think about making a 15n and an 8n if we were negative 8n if we were to FOIL it out. So, to get 5n squared, I'm thinking about 5n and n. To get to the 15, if I multiply the 5n by positive 3, and to get the negative 8n, if I multiply the n by negative 8, that'll do it for us. But of course, FOIL it out, check it if you would like. But we got it factored, it's set equal to 0. Now set each factor to 0. And solve. The one on the left, we have to do 2 steps, add 8 to each side. We get 5n equals 8. And then divide each side by 5. We get n equals 8 over 5. Now for the one on the right, we just subtract 3 from each side, and we already have n equals negative 3. So this one has 2 answers. 8 over 5 and negative 3. Now the last part of this section is 0 of a function is given a graph. This is very, very straightforward, except there is one new word, and you have to be careful when you write the answer. To determine the zeros of a function given a graph, to find the zeros, you set f of x, which is basically y, equal to 0. But where y equals 0, that's the same as the x-axis. So really what we are looking for the x values where the function hits the x-axis. You may know them as the x-intercept. The zeros of a graph have a similar name called the x-intercepts. The big difference is the x-intercepts are coordinate pairs, and they will always be written as that number, comma 0. And so I only have one example here because that's enough for this idea. It says for the following graph, identify all the zeros and x-intercepts. Well, all we need to do is look at where the graph hits the x-axis. And that does it in exactly one spot. This is our x-axis. It hits it right here at 2. So the number 2 is a 0. And the x-intercepts, well, we only have one because it only hits 1. It's the coordinate pair there, 2, comma 0. All right, so just to reiterate, to avoid confusion, the zeros are just the numbers. The x-intercepts are the coordinate pairs. Right, but if you have to answer one, you've really answered both. Even in all these previous problems that we did, we could have asked what are the x-intercepts, and we would just do the x value we got, comma 0. And this second one would have been D and E. But that's it for zeros. Like I said, it's not really much more than the solving the equation section. You just need to remember what a 0 is.